All right, so let's talk about this theorem, this lesson's special right triangles. Theorem 7.8 is called the 45-45-90 triangle theorem. And it's basically stating that if you have two angles that are 45 degrees and one angle that's 90, if you see in the picture, you can see that this angle's 45, this angle's 45, and that one's 90. If you have that, then you know for a fact that the hypotenuse, which is always the long diagonal, is the length of one of the legs times the square root of 2. So you see how they've put in x's for the lengths of the legs? And then you can see here that the length of a leg, which is x, times the square root of 2. It's always how you can calculate it. So hypotenuse equals leg times square root of 2. All right, so let's do a couple of. All right, so this is example 1. So we're going to find the length of the hypotenuse for both of these. So let's look at this first one. You have an angle that's 90 and an angle that's 45. Can we calculate what this third angle is?
45?
Yes, because all three added up always equal 180, right? So we know that that third angle is 45 degrees. If I know the third angle is 45 degrees, can I calculate the hypotenuse?
Yeah.
Yes, because it's the length of one of the legs times the square root of 2. Now the cool thing is, in algebra, you can just say that's the length of the hypotenuse. You don't actually have to solve it. Sometimes it'll have you solve it all the way if it's a simple solve, but this one, it comes out to be a crazy decimal, so you just leave that as the answer.
Okay.
All right, let's look at the B. So we know that this length is 3 square root of 2, this length 3 square root of 2. Let's look at our angles. This one's 90. Can we calculate what each of these are? Yeah, we can say they're each 45, right? Because all three added up equal 180. And if I subtract 90, I'm left with 90. So I know if I divided that, I'd get 45 here and 45 here. So since we know it's 45, 45, 90 triangle, we can say that this equals the length of the leg, which is 3 square root of 2, and all of that times the square root of 2. Right?
Yeah.
If you have a square root times a square root, those cancel. So you're essentially left with 3 times 2.
So there can never be 2 square roots of 2?
Well, they just cancel each other out. So they cancel the squares out, and then you're left with just 2. So what's 3 times 2?
6.
So the length of that hypotenuse is 6. All right. Oh, turned too many pages. All right, so we have this triangle. This is example 2. Find the lengths of the legs in this triangle. All right, first of all, is this a 45, 45, 90? Yes, it is. So because we know that, we can say that the hypotenuse, which is this measurement, 5 square root of 2, equals the leg length times the square root of 2, right? So now we can use that to solve. If I have x times the square root of 2, to get the x by itself, what would you do? Divide by square root of 2. Okay, these cancel, and I'm left with just x. And then these cancel, and I'm left with just 5. So my leg length is 5.
Okay.
Simple, right?
Yeah.
Yeah. The theorem that proves this is called the corollary. I don't know if I can spell it. Corollary to the triangle sum theorem. Triangle sum theorem. I'm sure you've written this in your journal, but from a lesson a while ago.
Pretty sure.
So just wanted you to remind you of that. All right, good?
Yeah.
All right. Let's look at the next one. Example 3. All right, example 3. Triangle WXY is a right triangle. Find the length of WX. So which one's WX?
WX is the
What's the fancy word for that?
hypotenuse.
Yep, hypotenuse. Okay. First of all, do we know what kind of triangle this is? We know it's a right, so we know this is 90, that's 45, so it is a 45. I can't read that. Stupidly. 45, 45, 90 triangle, right? So we know that because of that the hypotenuse equals 25 times the square root of 2, right? So then A, B, C, or D?
B.
Yep, so B would be our answer. You're going, there's no way it's this easy. Yeah, it kind of is. Do you want me to do any of the guided practice ones down there? Do any of those look scary? They all, I think.
3.
Okay.
Yeah, 3.
3, no problem.
Oh, it's just never mind. It's just,
You're like, oh, never mind, I know how to do it. Good?
no, I'm saying like I thought it's not as scary as it looks, but I just still want to.
Yeah, we can still do it. I'm going to draw it, though, because my book has the answer right here, and it will give it away. So bear with my mildly artistic skills. All right, so we know this is a right angle. This is a right angle. We know that each of these are 8. We basically have 2 triangles sitting on top of each other. So D, what measurement is D? What part of the triangle is that?
D, that's what part of the triangle?
Mm-hmm.
Like hypotenuse.
Hypotenuse, very good. So do we know what kind of triangle this is?
45, 45.
Yep, it's a 45, 45, 90. So we can use the rule that the hypotenuse equals, what's the leg length?
8.
And what's the rule times the,
Square root 2.
so is that the measurement for D?
Yeah.
Are you done?
Yeah.
There you go.
Yeah, I thought so.
Yeah, it just looks weird. It just has 2 triangles on top of each other, but
Okay.
that's good. All right, now let's look at our next theorem. All right, so you were dealing with the 45, 45, 90 triangle. This one is for the 30, 60, 90 triangle. Okay, so you see how you have your 90-degree angle still, but then you have your 30 and 60, which you can still, if you have one of these measurements, you can calculate for the other one. So you can still figure out whether triangles are 30, 60, 90. In this case, the hypotenuse is 2 times whatever the shorter leg length is. So in this triangle, which one's the shorter length?
2x.
This one. This is the shorter leg. So the hypotenuse, which is the long one, is 2 times whatever the shorter leg length is. That makes sense?
Yeah.
See how it's 2 times x?
Oh yeah.
And the shorter leg is x. Okay?
Yeah.
And then if you wanted to calculate the longer leg, you take the shorter leg times the square root, hold on, can't think of it. The square root of 3.
Yeah.
My brain turned off for a second there, sorry. Okay, so these two formulas you need to have in your journals because they're going to help you throughout this whole thing. And then make sure you label it 30, 60, 90 triangle. Okay? Let's do it. Okay, example 4. The logo on the recycling bin at the right resembles an equilateral triangle with side lengths of 6 centimeters. What is the approximate height of the logo? Okay, I didn't give you the picture of the logo. I just gave you their sketch of it. Okay, this is all approximate. So they just wanted you to practice doing this. So you have your equilateral triangle, right?
Yeah.
We know the measurements because this is 90 degrees here. And then you see these are 60, right? Mm-hmm. So what does that mean this one up here is?
30.
Yep, 30, 60, 90. Very good. So because of that, we can use our 2 rules that we wrote. How would you find the height here? I need to use a different color. Let's use green. Okay, so let's just look at this little one triangle. Ignore the other side, right? Mm-hmm. What is your shorter leg?
Shorter leg is the 3 centimeters.
The 3 centimeters, right? Mm-hmm. And the longer leg?
The 6.
What's the rule?
Hypotenuse equals 2 times the shorter leg.
Yeah, because the 6 is the hypotenuse.
Yeah.
We're trying to find the measurement of the longer leg, which is h, right?
Longer leg. So,
Anthony, will you go turn that off for me?
So it's 3 times the square root of 3.
Yes, 3 times the square root of 3. Very good. And you would actually do that because they want you to find the approximate. So you would take the square root of 3 times 3 and round it to 1 decimal.
5.2.
Yep. So the length of h is approximately 5.2 centimeters. So this lesson is almost primarily just have your little rules sitting there next to you and you'll be fine.
Yeah.
Do you want to do one more example? I can squeeze in real quick. All right, I cut off my 9 on the bottom, but I'll just draw it on there. This is a 9. Okay, so we have a 30, 60, 90 triangle. You can tell that already. And it says find the values of x and y and write your answer in simplest radical form. That just means you don't have to solve it all the way to the decimal. So let's find the value of x first. What is x as far as the legs and hypotenuse?
The shorter leg.
It is the shorter. Do we have a rule to find the shorter?
Yeah.
We could use the longer leg one, right? Because we know the longer leg. What's the longer leg?
9.
9 equals whatever the shorter leg is, so x times the square root of 3, right?
Yeah.
So then I can divide by square root of 3 to get x by itself.
Yeah. So it'd be 9.
X would be whatever 9 divided by the square root of 3 is. And we're leaving this in radical form. Oh, this is where we have to simplify.
It would be 5.2. 9 times divide.
Well, it wants you to leave it in radical form. So let me show you how to do this. When you have 9 over the square root of 3, you can't leave the square root stuff on the bottom. Mm-hmm. So in order to simplify that out, you multiply times whatever the bottom is over itself, like that. Okay, because remember, when I have square root times square root, it cancels the square, right? So then I have on top 9 square root of 3 all over 3. That makes sense so far?
Yeah.
And then you can simplify this because you can do 9 divided by 3, which is just 3. Mm-hmm. So then your final answer would be 3 square root of 3. So it looks crazy, but if you just remember the little weird rules, it works out. So that's x. Now we need to solve for y. Okay, y is the hypotenuse, right?
Mm-hmm.
So what's the rule for hypotenuse?
The hypotenuse equals 2 times
The shorter leg,
shorter length.
which we just solved as
3.
3 square root of 3.
Yeah.
Okay, so then here, the only thing you have to actually simplify is whatever 2 times 3 is.
6.
So then the hypotenuse is 6 square root of 3. So this is y. Okay?
Yeah.
Not terrible. Keep your journal open with you the whole time and you'll be fine. You're doing numbers 4 through 28, but just the evens.